Question 23. We're given 4 points on a circle, BCDF. We're given this angle x here. This BCDF is a cyclic quadrilateral also. And we've been given 2 triangles, ACD and BCE. We have angles 54 and 32 given, and we're trying to figure out what the value of x is. So in these types of problems where you're given multiple shapes, where there's multiple different angle rules that are used, and even circle theorems in the mix as well, and you've got an unknown angle somewhere, you basically need to find a way of connecting the information that you have been given, which is 54 and 32. Now, you're going to end up with angles along the way that will contain x's, but at some point in time, you will have started using 32 and get to using 54, or start using 54 and get to 32. You can also start using both and meet in the middle. There's many ways of doing this. So what I'm about to show just now is just one such way. First thing I'm going to do is just highlight the triangle that 54 is involved in, because it's good to be able to see these things separately. So we have 54 degrees here, and that is ACD. We then have this triangle here in blue, BCE, of which both of these share the angle C. Of course, what I'm drawing here is not to scale, but it's important to note that this angle here and this angle here match, so there's definitely a connection there. And then the other angle rule that I can see, or somewhere we're going to do angles, is in this cyclic quadrilateral, which gives us an x there, and also allows us to know what, I'll need a different color, what this angle is, because x plus this angle are going to equal 180. Now we'll come back to that, because where I suggested you start was with one of the numbers, so I'm going to do that now. Now in terms of the green triangle and the blue triangle, if you try and start with 54, you don't really have a way of figuring out what this is, because you don't know what this is, and vice versa. You can't figure out what this is because you don't know what this is. So I'm not actually going to start with the green one, I'm going to start with the blue one, because we also have an x in there. So we have 32 here, x here, and a third angle in that triangle. If we take 180, let me just call this the pink angle. It is technically BCE if I want to be really formal about this. So angle BCE. I could just highlight this in pink though, that's what I'm going to do. And we have 180, and we take away 32 from it, and we take away x from it, and that will give us the size of that angle, which is 148 take away x. So I can add to this picture 148 take away x. I can also add that information here now as well, 148 take away x, which then allows us to figure out something in this triangle. I can get this angle here in orange for D, which happens to also be the angle in orange here for D, filling in the other pieces of information while I'm at it. So what I'm going to do is I'm going to figure out the size of this angle here, and then I'm going to do something involving this red shape. So D, the orange angle, which technically is ADC or CDA, is going to be 180, subtract 54, subtract all of, so I put it in the bracket, 148 take away x, which is going to give me 126, subtract 148, but we end up with a double negative giving us a plus x, which gives us our positive x with a minus 22, which means this angle here is x minus 22, and this angle here is x minus 22. Now, we have a link that we know exists between opposite angles in a cyclic quadrilateral, and that is that these add together to make 180. So our x plus our x minus 22 is going to equal 180. Now, with these types of problems, like I said about how you could start with one angle and end up with the other, this, taken a step further, has actually made the link between, at least the way I've done this, between x and this creation here. Either way, you're going to get to a stage where you create an equation that you can actually solve. So to begin with, it was using these two to figure out what that was. But we didn't know what x was, so we kept going. We then used these two to figure out what that was. but we didn't know what x was, so we kept going. And then in the third shape, we suddenly had something that we could get a bit more clarity on, because when we set those equal to each other, we create an equation, and from there we can then solve it. So 2x take away 22 is 180. Add 22 to both sides, divide both sides by 2, giving us x as 101 degrees. The fact that this angle looks like a right angle in the picture is done deliberately so that you don't know whether or not it's acute or obtuse. So unfortunately, it's kind of difficult to know if you've gone wrong here, but the fact that our answer is close to 90, for me, is an indication that this is right. And of course, I have correctly answered this question, but just to kind of keep you in the loop for later on, you should normally see that it's acute if it's acute, or if it's obtuse if it's obtuse. But if they choose to make it close to 90, your answer is going to look close to 90, but you won't know either way. Done.